now clicking the, okay, there you go. We are now recording our session. So again, for our learning objectives this afternoon, we have number one, to identify electrical parameters, Ohm's law, and the different types of circuits. Number two, to learn how to analyze and solve mathematical problems with the help of Ohm's law. And lastly, to solve Ohm's law series and parallel circuit problems. So hopefully we'll be able to achieve all of our learning objectives for the next 2 days. Okay? So to start our discussion, let's go first with the electrical parameters. Okay? So when we say electrical parameters, these are usually the components no, that we, what they call this one, we encounter. Okay? Especially when we are in the field of electricity, these parameters are very common. Okay? Permi yun din ninyo sila madunggan. So what are the electrical parameters that we have? So number one, we have voltage. Number two, we have current. Number three, we have resistance. May I know who among you here are familiar with these terms? With these terms. Now, kindly click the raise hand button if you are familiar. If you have heard it before, no? Or maybe somebody mentioned it while talking to you. Okay, very good, no? Especially with our fathers, di ba? Kanang mahilig atong mga father magkubi-kubi sa itong mga electrical wires. They know these terms. No, they are very familiar with these terms. Okay, very good. Or even our uncles, our brothers, no? So our electrical parameters, number one, we have the voltage. When we say voltage, this is also known as electromotive force, no? That pushes the electrons into the conductor. Okay, so it is the force. Without the voltage or the electromotive force, our electrons won't be able to move, no, or to flow into the conductor. Okay? So kibali, no? Pusher ang atong voltage, no? Just kidding, 'di ba? Siya ang gatulod, no? Or the voltage is the force that allows our electrons to uh, move along our conductor. Okay? So if voltage is not present, our electrons won't be able to move from the source going to our conductor and powering up our appliances or any gadgets that you connect to our circuit. Okay, so that is voltage. Next, we also have what we call current. Current naman is the actual flow of electrons in the conductor. So again, if voltage is the force that pushes the electrons, no? Once the electrons are pushed towards our conductor, the actual flow, ang ilahang movement is what we call current. Okay? So without voltage, current won't uh, be possible as well. So they always come hand in hand. Okay? So ang ato ang electrons can only flow, can only have the current if voltage is present. Understood? Nasabtan? Okay, very good. Then lastly, no, we have resistance. From the word resist, okay, resistance is the opposition of the flow of electrons in the conductor. So anything that stops the flow of electrons into the conductor, or even, no, there are times nga, even if i-slow down lang niya ang flow sa electron into the conductor, that is already considered as resistance. Okay? So our resistance can come in different forms. There are sometimes, no, the gadgets that we plug into the circuit that we have, ato ang TV, ato ang laptops, they can be considered as resistance, though they do not stop the flow of electrons, but somehow they slow it down, no, kay gaka-consume sa ato ang mga gadgets ang current. Okay? So instead of going from the source, positive pole of the source to the conductor, then go straight back to the negative pole of our source of current, naa siya kibali stopover, no? So naay interruption gamay. Okay? So that is what we call resistance. Okay? So again, when we say voltage, this is the force, electromotive force that pushes our electrons into the conductor. The current is the actual flow, no, ang movement yun sa electrons into the conductor, and resistance is or anything that opposes, no, or stops, prevents, or slows down the flow of our electrons. Okay, so these are our electrical parameters. Nasabtan so far? Kindly click the raise hand button if nasabtan ang three electrical parameters. So it's very important that you familiarize these parameters because you will be encountering these, no? Every time you do problem solving when it comes to circuits. Okay. Sige. So when it comes to problem solving, of course, we cannot just write voltage, current, and resistance every time mag-solve mo, no? Okay. It will take long time. So we have the following symbols, okay, for each parameter. It also has its own unit of measure. When we say unit of measure, this is what we use to measure, no, or to identify the amount of voltage, amperes, or a current and resistance, okay, in your circuit. And of course, our unit of measure also has their own symbols. Okay, so let's start first with voltage. So voltage, the symbol for voltage is V or letter E, capital letter V or capital letter E. So V is, sorry, KV is for, of course, voltage, no? Voltage. Ang E, aha man nato ni nakuha. Going back to our, aha nato nakuha ang letter E. Where did we get letter E? V is for voltage. But why do we have letter E? Is it electron? Okay, going back to our definition of voltage, electromotive force. Okay, so voltage is also known as the electromotive force. That's why we also have letter E as the symbol for our voltage. So either of the two, no? But most of the time, what we usually use is letter V, di ba? Because it's easier to remember, no? Okay, voltage, letter V. So mas dali siya ma-memorize. Okay, but either of the two can be used. Okay, for the unit of measure naman for our voltage, okay, its unit of measure is volt or volts. Of course, pag plural, volts, no? Pag singular, volt. And the symbol for volts is same with voltage, letter V, gihapon na siya. Okay? So that's our voltage. Next, we also have current. Unit of measure, symbol for electrical parameter na current is letter I, no? Letter I. The unit of measure is ampere or amperes, and the unit of measure symbol for our amperes is amps or as simple as capital letter A. Okay, so either of the two will work as well. Then lastly, for resistance, okay, the symbol for our resistance is capital letter R. Unit of measure is ohm or ohms, no? Then the symbol for ohms is the Greek letter for omega. Okay? So mura siya letter O but naa siya tiny tails on both sides or both ends of letter O. So this is Greek letter for omega. Okay? So it's very important that you memorize the symbols for each unit of measure because when we do the problem solving na, I will mark wrong if your answers doesn't have the symbol for the unit of measure. So please do memorize each symbol and each unit of measure. Okay? Understood? Okay, very good. Sige. Any questions so far before we continue? Okay, sige. If there are no questions, let's now proceed to the next slide. Okay, next. Okay, if you can still remember from our discussion last week, no? George Simon Ohm introduced to us the law which tells us the relationship between voltage, resistance, and current. Okay, that law is what we call Ohm's law. So we have here, according to Ohm's law, the amount of current passing through the material varies directly with the applied voltage. What do we mean by ang current daw, no, the current, the amount of current passing through the material varies directly with our voltage. What do we mean by the term varies directly? Anyone? So they vary directly, or in other words, no, we can also have this as directly proportional. What do we mean by that? When we say directly proportional, si current daw is directly proportional with voltage. What do we mean by that? Anyone from the class? Wala? Okay, sige. When we say equal, is it equal? Thank you for your answer, Hans. Okay, joke? Is it a joke? Okay. When we say varies directly, no, according to Ohm's law, the relationship of current and voltage with each other is directly proportional. Okay, this only means that when current goes up, see voltage goes up as well. Okay? But if si current munaog siya, the amount of current goes down, the amount of voltage also goes down. So whatever happens to current, it also happens to voltage. Okay? So that is what we mean by directly proportional. When current goes up, voltage goes up as well. If current goes down, voltage goes down as well. And vice versa. Kung si voltage pod ang musaka, musaka pod si current. Okay? If munaog si current, munaog pod si current. Understood? Nasabtan? Okay, very good. Then, aside from that, no, we have here if okay, this we also have here the relationship of current and resistance. So if si current, no, current, the amount of current passing through the material varies inversely with our resistance. So varies inversely. Now we have here si current varies inversely, or in other term, or in other words, inversely proportional with our resistance. What do we mean by that? So if si directly proportional, musaka si current, musaka pod si voltage, how about inversely proportional? Si current og si resistance. So, okay, very good, Ina. I can see you. Okay, very good hands. I can see your hand gestures. Okay, very good. So, inversely proportional if si current musaka ang iyahang amount, no? If the amount of current goes up, the amount of current resistance pala goes down. Okay? So that is what we mean by inversely proportional. When current goes up, resistance goes down, or if current goes down, si resistance naman ang mo saka, and vice versa. Okay? So from that, so we have here current is directly proportional with voltage, and we have here current is inversely proportional with resistance. So we get the very first formula from Ohm's law. So from here, naatay first formula from Ohm's law. So that we have I is equal to V over R. Or when you want to solve for the value of, unsa gani ang I? Current, voltage, or resistance?
Current.
Current, very good. If we want to solve for the value of current, all we need to do is to divide voltage by resistance. So I is equal to V over R. So that is the very first uh, formula from Ohm's law. Nasabtan? Okay. We still have two other formulas, no? But in order for us to memorize these formulas easier, no? All we need to do is remember the pyramid of Ohm's law. Okay? So earlier, di ba, we got the formula in getting the value of current. So from the pyramid, for you to remember the formula easily, when you want to look for the value of current or I, all you need to do is cover letter I, then you get V over R, or voltage divided by resistance. Okay? So that's it. If we want to solve for, so this is our formula number one. If we want to solve for voltage, all we need to do is cover letter V, then we have I is equal to R. So this is V is equal to I times R. Formula number two. Okay, then lastly, if we want to solve for the value of resistance, cover letter R, then we have R is equal to V over I. So that is our formula number three. Okay, so timanan lang nato ang pyramid of Ohm's law in order for us to remember the three primary formulas of Ohm's law. Okay? Sige, nasabtan, kindly click the raise hand button if nakuha ang mga formula. Okay, very good. Okay, very good. Sige. Now, okay, let us try to prove, no, if the statement coming from Ohm's law is correct. If sakto ba gyud nga si current and si voltage are directly proportional, and if si current and resistance are inversely proportional. So how do we do that one? Okay, let us prove Ohm's law if it is correct, no, by solving a problem. So we have here for problem number 1, by the way, this is what we call a circuit diagram. No, we will know circuits later on. Okay, so we have here a circuit diagram with the following given value. So naatay 20 volts, that is for our voltage. Then we have 2 ohms, which is the value of our resistance. So we are being tasked to look for the value of our current. Okay, so there you go. Voltage is equal to 20 volts, resistance is equal to 2 ohms. So we are going to solve for the current, no? I. Sige, what formula are we going to use? Sige, from the pyramid of Ohm's law. Okay, very good. Let's just cover letter I, no, or current. Since we want to solve for its value, cover it. Then we have the formula V over R. So the formula that we will use is I is equal to V over R. So simply substitute dayon. That is equal to, what's the value of voltage? What's the value of our voltage? Okay, very good. 20, unsa man na siya, Georgina? 20 eggs, 20 glasses of milk.
Volts.
Okay, 20 volts. Do not forget to always write the symbol for its unit of measure ha. So 20 volts divided by, what's the value of our resistance?
2 ohms.
2 ohms. Okay, very good. 2 ohms. So all you need to do is to multiply. So 20 divided by 2, ginuko lisod kaayo ni nga nga problem. 20 divided by 2, only geniuses can solve for this one. What's the answer? Unsay 7 Abdullah? Okay, very good. The answer is 10 amps or 10 amperes. Okay, very good. So 20 volts divided by 2 ohms, that is I is equal to 10 amps or 10 amperes. Okay, very good. Kindly click the raise hand button if you got the same answer with me. Abdullah, what happened? Anong 7 ang imuhang answer? Okay, sige, very good. Joke lang, sir. Okay, very good. Abi ko. Okay, sige. Okay, very good. Now, again, let us prove the statement if voltage or current is really directly proportional with our voltage. So this time, I will be increasing the value of our voltage. So from 20 volts, no, we'll make it 40 volts. Same lang ang value sa ato ang resistance, but we increase the value of our voltage. So this time we have 40 volts as the value for our voltage, 2 ohms still for our resistance, and we solve for the value of our current. Okay, very good. So these are our given. Voltage is equal to 40 volts, resistance is equal to 2 ohms, then we are going to look for the value of our current. So since we are still looking for the value of our current, we use the same formula. So let's substitute. This will become 40 volts divided by 2 ohms. Another problem that only geniuses can solve. What's the answer? Okay, very good. Genius gining mga taga 10 IO. Daghan kay naka-answer. Very good. Okay, so 40 volts divided by 2 ohms, okay, our current is 20 amps or 20 amperes. Okay, so from that, what have you observed? Sakto ba ang statement nga when current increases, voltage also increases, or when voltage increases, current also increases? Okay, very good. No, it's correct because from 20 volts, we increase the value of our voltage to 40 volts. No, nag-increase ta. So as you can see, ang atua pong current, no, ang value po sa atuang current, nag-increase po siya. Ang answer from the first problem is 10 amperes. Sa second problem, nahimo na siyang 20 amperes. So therefore, when V increases, the I also increases. When the V decreases, the I also decreases and vice versa. Okay? So the first statement from Ohm's law is correct. Diba? Sakto siya. Current and voltage are directly proportional. Okay? Sige. Now, we're not yet done proving if Ohm's law is correct. This time, let us prove if the second statement of Ohm's law is correct, which is current is inversely proportional with our resistance. Okay, so let us try to solve another problem to prove whether the second statement of Ohm's law is correct. So this time we have another circuit diagram. Okay, the value for our voltage is 12 volts. Then we have the value for our current is 5 amperes, no, or 5 amps. So we are being asked to look for the value of our resistance. Okay, so here are our given. Voltage is equal to 12 volts. Current is equal to 5 amps. And we're going to look for the value of resistance. So what formula are we going to use? Let's look again in our pyramid of Ohm's law. So, once again, itong electrical parameter atong ginapangita, we are looking for resistance. Very good. So we are just going to cover letter R. Okay, so you have there the formula. R is equal to V over I. So we'll substitute. So V is 12 volts divided by I or 5 amps. So what's the answer? 12 divided by 5. Lisod na pod kaayo nga question, di ba? Okay, or be very careful with your unit of measure. Tanawa o resistance ang atong ginapangita. So what's the unit of measure? Ohms. Very good. Pero na nag-answer og amps. Insa man na? O, ina. Nag-answer kag amps. Be very careful ha. Kay again, automatic nga wrong ang answer if the unit of measure is wrong. So be very careful, good. Okay, very good. So we divide 12 by 5. So 12 divided by 5, that is 2.4 ohms. Okay, very good. Now, let us try to increase the value of our current. So from 5 amperes, no, or 5 amps, let's make it as 6 this time to see if sakto ba gyud ang Ohm's law. So same value for our voltage, 12 volts, but this time we increased our current from 5 amperes. Let's make it 6, and we are going to look for the value of our total resistance. So say given voltage is equal to 12 volts, current is equal to 6 amperes, then resistance is question mark. So same formula will be used. R is equal to V over I. What's the answer? This will become 12 volts divided by 6 amperes. Okay, wait lang. Another difficult question coming from our lesson. Okay, very good. Then nakakuha sa answer, no? Very good. 12 divided by 6 is 2 ohms. Okay, very good. So resistance is equal to 2 ohms. So can we say that the statement from Ohm's law is correct? Na ato ang current is inversely proportional with our resistance. Okay, very good. Yes, that's correct, no? Because when we increase the value of our current from 5 amperes to 6 amperes, ang value sa ato ang resistance nag-decrease, di ba? From 2.4 ohms, it became 2 ohms na lang. So therefore, when current increases, the resistance decreases. And when the current decreases, the resistance increases and vice versa. So from here, we can say that Ohm's law is correct. Okay? Nasabtan so far? Understood? Okay, very good. Sige. Now, let us go to the different types of circuits that we have, no? Okay, before we dive into the types of circuits, let us try to define first what is a circuit. So we have here a circuit, no, is the pathway of electrons from the source to the components then back to the source. So as you can see, naata dari no ang atuang what they call this one circuit. Okay, basically when we say circuit, this is just a pathway, no, in order for us to use the current, diba? So that electrons can move, can flow, and we can power up our appliances. So kanang inyuhang mga lighting fixtures, inyong mga suga, kanang inyuhang mga appliances, no, kanang inyong mga outlet, those are parts of a circuit. Okay? Without circuit, we won't be able to enjoy the perks of electricity. Okay? So naata dari no components sa atuang circuit, we have the source, number 1. We also have the conductor. Of course, ang conductor mo na ato ang electrical wires, di ba? That we use so that electrons can flow from the source going to the conductor. Then, of course, naapod tay load. So, kaning load, usually they are the ones who uses, okay, the current. So that ma-power up nato na siya. So kanang inyong mga cellphones nga inyong gina-charge, inyong laptops, they are considered as loads. Okay? Sige. Understood? Okay, very good. Sige, let's now move to the next slide. So let's now have the different types of circuits. So the first one that we have here is what we call the simple circuit. When we say simple circuit, it means that it contains the minimum things needed to have a functioning electrical circuit. Okay, minimum, meaning mauna siya ang pinakagamay nga mga materials lang that you need in order for you to create a functioning electrical circuit. So unsa may mga things that we need, no? In order for us to create a simple circuit, of course, we have one source. Dapat naa kay one source, naapod kay one conductor, and naapod kay one load. So these are the minimum things that we need in order for us to create a simple circuit. Once gani mulapas na og one ang ato ang source, mulapas nag one conductor, mulapas nag one load, then that is not simple circuit anymore. Okay, so isa-isa lang yun. Okay, isa ka source, isa ka conductor, and isa ka load in order for us to create a simple circuit. Understood? Can you click the raise hand button if nasabtan ang simple circuit? Okay, very good. Sige, next. Next on our list is what we call series circuit. So, as you can see, no, ang atuang series circuit na ana siya more than one nga load. Diba? As you can see, na natay 1, 2, 3. So we cannot consider this one as a simple circuit anymore. So we call this circuit as series circuit. Okay? Here are the characteristics, no, that we need to remember in order for us to identify if a circuit is series. So number one, siya, it contains only one path for the current to flow. So as you can see, naalang tayo isa ka conductor connecting our source to our loads. Diba? One path lang siya. One conductor. Okay, that is a characteristic of a series circuit. Next, loads are connected on one wire or line or in a straight manner. So as you can see, ang katong one path nato is only, no, the line that connects our three loads. Okay, so as you can see, wala na kay lain wire makita dira. Ang atuang mga loads are connected in a straight manner sa atuang wires or along the wire siya naka-connect. Okay? Then lastly, loads are dependent on each other. Okay, what do we mean by that? Once si load number 1 maguba, no, kana siya, automatically load number 2 and load number 3 will not function anymore. Okay, why? Because they have one conductor lang man connecting them in one line. So pag naay magka-problema sa ilaha, automatically, the other remaining loads will not function anymore. Okay? One good example of this is ato ang Christmas light or sometimes, di ba, we call it a series light, no? If you have noticed, once na ay magubang isa lang ka-bulb sa ato ang Christmas light, automatic, the entire Christmas light will not function anymore. Have you noticed that? No, because they are connected in a series circuit manner. Understood? Okay. By the way, I forgot to tell you, no, kaning atuang arrow, kana siya, this arrow, this red arrow, tells us the flow of the current. So from the positive side of our source, clockwise dayon siya, going around the circuit, balik dayon siya sa negative side of our source. Okay? Always gina siya clockwise, dili pwede nga mag-start sa negative going to positive. Always gina siya positive going to negative. Understood? Okay, very good. Okay. Since in our example, no, we have 3 loads, automatic pod, no? Again, ang load nato is for the resistance. Okay? Pag naagani kay loads, automatic na apod kay voltage and current. Di gina siya mawala. Always gina sila mag-uban, ha? So if you have 3 loads, naapod kay 3 ka electrical parameters. So you have V sub 1, V sub 2, and R sub 1. You have R sub 2, V sub 2, and I sub 2. R sub 3, V sub 3, and I sub 3. Kanang mga I sub 1, I sub 2, and I sub 3, That is referring to the number of loads. Okay? So pag mula pa sa check 3, pag naatay 4 ka loads, napatay R sub 4, R sub I sub 4, and V sub 4. Understood? Sabtan? Okay. Aside from that, we also have our total voltage, meaning ang voltage nga nagamit sa 3 ka loads, naapod tay total current and total resistance. R sub T, I sub T, and V sub T. Because at the end of the day, we are going to get man the value of the voltage no, that is used for the entire circuit. Okay? Nasabtan? Kindly give me the word okay in our chat box if nasabtan. Okay, very good. Okay, thank you so much. Sige, next. Let's now go to the next circuit that we have. Okay, parallel circuit naman okay, is another type of circuit, no? Here are the characteristics of our parallel circuit. It has more than one path for the current to flow. Okay, as you can see, no, naatay 1, kani siya 1, naatay 2, and naatay 3. Unlike our series circuit nga, one line lang yun siya, ang atuang parallel circuit, it has more than one path. Okay, for the current to flow. In this case, in our example, we have three paths because we have three loads as well. So for each load, dapat na akay one path for them. Understood? Okay, next. Loads are connected across the wires or the lines. If atuang series circuit, the loads are connected along the lines, no? Ang atuang parallel circuit, our loads are across or in the middle of our circuit. Okay, inguna na iyahang arrangement. Then lastly, loads are independent from each other. Anong independent man siya? Unlike our series circuit that they are connected along the line lang or in one line, in our parallel circuit, each load has its own connection or naa siya own conductor. So whenever load number 1 gets busted or madaot siya, loads number 2 and number 3 will still function because naa sila'y own line nila. The current will still flow towards them. Okay? Nasabtan? Okay, very good. Sige. Then let's go now to the last type of circuit that we have. Okay, series parallel combination circuit. This is a combination of a series and a parallel circuit. So, i-combine ang series of parallel circuit nato, no? Okay, looking at our example, as you can see, si load number 1 nato, Dari, it is connected along the lines, diba? So, this is connected to our circuit in a series manner. But loads number 2 and loads number 3, they are connected across our circuit. So, they are already considered as parallel circuit or they are connected in the circuit in a parallel manner. Okay? So, combination siya sa duha ka circuit. Sige. Nasabtan? Any questions so far before we proceed to the next slide? Questions, clarification? Sige. Let's continue. We now have 15 minutes left, no? Dali naman lang ni. Okay. So, now we are in problem solving na. So, we will still be using the formulas from Ohm's law, but since we are going to focus in a series circuit and a parallel circuit problem solving, we also have conditions that we need to remember in order for us to get the value of the total resistance, total voltage, and total current. Okay? So first, the total resistance is the sum of the individual resistances. So for you to get total resistance or R sub T, all you need to do is to add R sub 1 plus R sub 2 plus R sub 3 plus dot 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 R sub n. R sub n will depend no kung how many loads are connected in your circuit. So in case mo abot siyag 4, maabot siyag 5, all you need to do is to continue din plus R sub 4 plus R sub 5. Okay, so again, to get the value of total resistance, all you need to do is add the individual resistances. Okay, next. To get the total voltage, the value of total voltage, same with total resistance, all we need to do is to add the values of the individual voltages. So that becomes total voltage, or V sub T, is equal to V sub 1 plus V sub 2 plus V sub 3 plus dot 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 V sub n. Again, V sub n will depend on how many loads are connected in your circuit. Okay, then lastly, for the total current is constant all throughout the circuit, meaning whatever the value is of your total current is also the value of your individual current. So that becomes I sub t, or total current, is equal to I sub 1, equal to I sub 2, equal to I sub 3, equal to dot 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 I sub n. Again, I sub n will depend on how many loads are connected in your circuit. Okay? Please remember that these conditions are only applicable for series circuit. Okay? Series circuit lang ni siya applicable. Sige, nasabtan? Sige, kindly take a screenshot of the formulas before we go to the next slide, no? Sige, are you done taking screenshot? Okay, very good. Sige. Okay, now, let's try to solve a sample problem. So we have here a series circuit, no? As you can see, nga nung mabalaan man nato nga series circuit siya. Okay, looking at the diagram, okay, we have here, okay, naa siya one line lang coming from the source, connecting our loads, then going back to our source, no? Then as you can see, our loads are connected along the line, di ba? So naa siya sa side lang. We have R sub 1, R sub 2, and R sub 3. So this is a series circuit. Nasabtan? Okay, by the way, another trick that you need to remember, every time you have a value of voltage written near your source, automatically that becomes the value of your total voltage. Okay? Always remember that every time na atay isulat nga value for voltage near our source, automatically that becomes our total voltage. So we have the following given values. By the way, pag mag-solving na ganita, do not forget to copy the diagram. I-draw ninyo ang diagram. Okay? Okay, that will give you additional points. So let us identify the given values. So we have here, total voltage is equal to 9 volts. R sub 1 is equal to 3 ohms. R sub 2 is equal to 3 ohms. Then R sub 3 is equal to 3 ohms as well. Okay, so now, let us try to identify what are the missing parameters, or meaning, kanang required nato nga pangitaon. Okay, sige, let's go back here. Okay. Again, unsa ganito kong ingon, kani siya, this is your total voltage, di ba? Kay written near the source man siya. So since we have R sub 1, automatic na apud tay unsa pa tong electrical parameters nga naa dari? Naatay R sub 1 man. So automatic we have okay, current, or I sub 1. Very good, Abdullah. Then we also have what else? Aside from current, R2, naanatay R sub 2. Dari sa ta sa load number 1. Okay, naatay R sub 1, naatay I sub 1, and we also have, very good hands, V sub 1. So automatic na atay resistance, current, and voltage for load number 1. Next, since we have R sub 2, automatic na apud tay I sub 2 and V sub 2. Okay, same goes with our third load. Naaman tayo R sub 3, so automatic we have I sub 3 and we have V sub 3. Okay, kanilang ba ang ato ang pangitaon? Mao lang ba ni ang mga parameters that we need to look to solve for? Okay, naaman tayo total voltage. So this means naapod tayo. Okay, very good. We also have total resistance and total current. Okay, so the missing parameters that we need to solve, we have total resistance, total current, V sub 1 or voltage 1, V sub 2, V sub 3, I sub 1, I sub 2, and I sub 3. Okay? So mo na ato ang pangitaon. Sige, let's start answering now. Okay, very good. Okay, so now, unsa man nga electrical parameter ang ato ang isolve pinakauna first. From the given, of course, we need to check sa given, no? kung unsay pwede nato i-solve. Naatay total R sub 1, we have R sub 2, we have R sub 3, and we have total voltage. What electrical parameter can we solve from the required? What do you think? Current? Nganong current man, Hans? Look at the given values. Naatay R sub 1, R sub 2, R sub 3. Then we also have total voltage. Unsa man na nga R, Frederick? Please be specific. Resistance. Okay. Resistance. Okay. To be specific, atong isolve ang total resistance. Nganong total resistance man? Because since we already have the value of R sub 1, R sub 2, and R sub 3, and again, going back to the condition given by series circuit, to look for the value of total resistance, all we need to do is to add the value of individual resistances. So this will become R sub 1 plus R sub 2 plus R sub 3 is equal to total resistance. Then let's substitute. So this will become 3 ohms plus 3 ohms. Please be bear with my handwriting. No, I'm not really good at using this pen, tablet, whatever it is. Plus 3 ohms. So, i-total din na to. 3 plus 3 plus 3. What's the value of our total resistance? Ila? 3 plus 3 plus 3. Okay, very good. 9. Unsa man na siya nga 9? Do not forget to write 9 ohms, no? Ang unit of measure. Okay. Then, if you have your final answer na dayon, please don't forget to write it inside a box, no? Para mas easier sa kwa pag-identify kung unsa inyong answer. Especially with our solution, it can be very messy, no? Or confusing. So, if you have your final answer na, write your final answer inside a box. Okay, very good. 9 ohms. Okay, we're done with total resistance. Next, unsay isolve nato next? What do we solve next? Current. Anong current man, Frederick? Unsa man nga current? Is it I sub 1, I sub 2, I sub 3, or I sub T? Please be specific. Total. Okay, nganong total man? Why can we solve for the total current na? What is the reason? Unsa ganito condition sa total current sa series circuit? The amount of current is constant all throughout the circuit. So I sub T is equal to I sub 1 equal to I sub 2 equal to I sub 3. Can we solve for the value of total current now? What do you think? Okay, yes, that's correct. We can solve for total current na. But what is the reason? What do you mean by no, Frederick? You do not agree that we cannot solve for total current? Okay. Sige, no? From the condition given by series circuit, we cannot really identify the value of total current. Kaya wala man tay value pod sa iyahang individual currents. But let's go back to Ohm's law. Unsa gani ang formula to get the value of current sa Ohm's law?
V over R.
V over R. Unsa man ang pwede nato magamit? Yes, we can use that formula. Do we have the value? Since total current ni siya, do we have the value of our total voltage?
Yes.
Yes, naa. Okay, what's the value? 9 volts. Do we have the value for our total resistance? Naa. 9 ohms. So, we can solve for the value of our total current. So, this will become 9 divided by 9. 1. Very good. 1 amps. Okay. So, since naa na tay value sa ato ang total current, dari na day nato ma-apply ang condition from series circuit. So, the value of current is constant. So, 1 amp, which is the value of our total current, is also the value of our I sub 1, I sub 2, and I sub 3, or our individual currents. Okay? Put them inside the box. So, we are done na din solving for I sub T, I sub 1, I sub 2, and I sub 3. Okay. Yes, Ian, you are raising your hand. Okay, nasabtan? Okay, you may. Sige. Nasabtan ra ba giunsa nato pagkuha ang I sub t? Please do not forget how we can use the formulas for Ohm's law in solving series circuit. Okay? Next. Okay. As you can see, V sub 1, V sub 2, and V sub 3 na lang ang nabilin. We can solve for them na because we also have the value for I sub 1, I sub 2, I sub 3, R sub 1, R sub 2, and R sub 3 as well. Okay? So let's start with V sub 1. What formula are we going to use? V sub 1 is equal to what formula? Ohm's law. Okay, very good, Frederick. I times R. No, I sub 1 times R sub 1. So this is 1 amp times R sub 1 is 3 ohms. So what's the value of our total voltage? 1 times 3. This is 3 volts. Okay, very good. Next, V sub 2. Okay, since we are still looking for the value of voltage or V sub 2, we still use the same formula. So this will become I sub 2 times R sub 2. So this is 1 amp times 3 ohms gihapon is equal to 3 volts. Okay, very good. Then lastly, V sub 3 is equal to I sub 3 times R sub 3 is equal to 1 amp times 3 ohms. So that is 3 volts gihapon. Okay, we're done with V sub 1, V sub 2, and V sub 3. Are we done? Humana ba ta? Okay, no, we are not yet done. In order for us to see if our answers are correct, of course, we need to do the checking. Okay. In the checking, no, in checking your answer, you can use any of the given values sa ato ang problem. Just to make sure lang na we get an accurate answer. So this time, let us use the value for our total voltage. So total voltage is equal to, okay, ato ang gamiton ang kaning, let's use the condition from series circuit. So di ba total voltage is equal to V sub 1 plus V sub 2 plus V sub 3. Or you can also use the formula from Ohm's law. But kani lang, ako lang gigamit ang V sub 1 plus V sub 2 plus V sub 3 kay wala pa man siya nagamit sa atoang solution. So let's substitute dayon. This is 9 volts is equal to 3 volts plus 3 volts plus 3 volts. Okay, 9 volts is equal to 9 volts. So our answer is correct. Okay? As easy as that. Nasabtan? Okay, very good. Sige, any questions so far? Any questions? Okay, sige. Later, no, after this one, I'll be posting a problem, no, sa ato ang socials. I want you to answer it and that will serve as your synchronous activity number 3. Yes, number 3. Do not upload it lang sa dayon sa silid. I will instruct you tomorrow, tomorrow na dayon sa ato ang next session on how to submit your assignment. Okay? Sabtan? Okay, any questions so far? Questions, clarifications, violent reactions? Sige, if there are no questions, let us now have our closing prayer. Sige. Sige, prayer
Start.
leader. Sige, you may start. Hans.
For the Catholics, please make the sign of the cross, and for the non-Catholics, please bow down your heads. Let's pray. Dear God, Heavenly Father, thank you for this beautiful day you give it to us. And as we end our DLE session this afternoon, may you guide us, protect us always. In Jesus' name, pray. Amen.
Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Okay? Thank you so much, Hans, for leading our closing prayer, no? And of course, before I go, allow me to leave this message to you guys, no? Of course, our session is not complete without our quotation of the day. So allow me to share lang sa for a little while. Okay, there you go. Okay. There you go. From Mother Teresa, no, if you know who she is. Okay, kind words can be short and easy to speak, but their echoes are endless. So please do not forget to be kind to others, no, especially when we are talking to them. And of course, do not forget to be kind to yourself as well. Okay? Thank you so much, Ten I, for actively participating in our session this afternoon. Sorry, Win, what's that?
Nakipangutana.
Ah, yes. What's your question?
Asa gani ni makita na recorded, sir? Nga,
I will post the video link later pod sa ato ang socials. So assignment and the video link will be posted sa socials right after ma-process siya kay it will take time pa no for Google to prepare the video. So maybe later tonight na ko ma-post ang video. Okay, together with the assignment.
Thank you, sir.
Okay, sige, you're welcome. Sige, thank you so much, Tenay, for actively participating in our session this afternoon. I'll see you all tomorrow. Stay safe, stay healthy. God bless you all. Goodbye and thank you, everyone.
Bye, sir. Thank you.
Sir, thank
Bye.
you.
Thank you so much.
Bye, sir. Thank you.
Bye. Thank you.